Okay, good day. This is Math 140 College Algebra. I'm Professor McCully. This is lesson 1-3, solving equations algebraically. Let's get right to it. So today we are going to solve linear equations in one variable. We're going to find x and y intercepts of an equation algebraically, and we're going to use the linear equations to model and solve real-life problems. So first, a couple definitions. An equation is an identity if any value makes the equation true. An equation is conditional if only one or infinite number of values make the equation true, and the equation is a contradiction if no values make the equation true. Another review from Algebra 1, the order of operations. Please excuse my dear Aunt Sally is the mnemonic device. And just as a quick review, this is going to be parentheses or grouping symbols. And when I say grouping symbols, I'm talking about like tangent, absolute value, and those types of things. Excuse are going to be exponents as well as logarithms. And when we're talking my dear, we're talking about multiplication and division. And Aunt and Sally is add and subtract. Now, when you are evaluating, that's not very good. Let's see if we can do a better job. Evaluating, evaluating. I think that's right. And we're going to start here at the top and work down, but when you are solving an equation, yeah, you are going to start at the bottom and work your way up, okay? And so just as a quick example, a couple examples of this, it says, are the following an equation, an identity, a conditional, or contradiction? So the best way for us to talk about how we're going to do that is we're just going to solve and see what happens. And so following my order of operations here, I'm going to, again, work at the bottom. I have a subtraction. We're going to do the opposite. And so we're going to add 6 to both sides here, and we'll get 3x equals to 7. And then we're going to divide by 3, and I'll get x equals 7. Oops, get the right tool there. Equals 7 over 3. That is a single value, so this is conditional. And then in this one, before I can do anything, I'm going to distribute. And I'll get 3x minus 6 equals 3x minus 6. Since that's the same thing, any value, so any value will work. This is going to be an identity. And we could solve this. I could add 6 to both sides. That would give me 3x equaling to 3x. If I add 6 to both sides, if I divide both sides by 3, I get x equaling to x. So any number that you plug in for x will equal itself. This is an identity. All right. A definition of a linear equation. And a linear equation in one variable is an equation that can be written in the standard form ax plus b equal to 0, where a and b are real numbers with a not equaling to 0. And to solve a linear equation, we follow the order of operations. We start with the original equation, and then it shouldn't be equations. It should just be equation there. Sorry about that. We're going to add or subtract b from both sides, and then we're going to divide both sides by a, and that will be our solution. So again, a couple quick linear examples here. A couple more solving here. In this case, some might say we're going to distribute the 3/4 to both sides, but since it's a fraction, I'll get 3/4 z, and then I'll get 12/4. And so I think I'm actually going to multiply by 4 over 3. Now, when I multiply by 4 over 3 here, so I'm going to go 4 over 3 times the quantity 3 over 4 z minus 4, and then multiply this other side by 4 over 3 times the 6. These two will cancel. That'll leave me just z minus 4, which is good. And then when I multiply 4/3 times 6, well, 6 is really 6 over 1, and I can cancel along a diagonal. So 3 and 6 both have a divisor of 3. So if I divide a 3 out of 3, I get 1. If I divide a 3 out of 6, I get 2. And so 2 times 4 is 8. 1 times 1 is 1. I get 8 over 1. That's going to be 8. And so here I'm going to add 4 to both sides, and it'll give me z equaling to 12. And that is my solution for that one. Here, because I got whole numbers, I am going to distribute. And that'll give me, if I distribute here, I'll get 3x plus 9 equaling to, let's see here. If I distribute, I'll have 5 minus 5x minus 1. And I think what I'll do here is simplify first. And I'll simplify because I have a common, I have like terms here on the right-hand side. So I have 3x plus 9 equaling to, let's see here, 5 minus 1 will be 4 minus 5x. And then I'm going to say, let's collect all our x's on the left-hand side. So we'll add 5x to both sides. And so 3x and 5x will give me 8x plus 9 equaling to 4. And so we're going to subtract 4, or no, let's not subtract 4. Let's subtract 9 from both sides. And that way we're getting the whole numbers on the right-hand side. So they give me 8x equaling to negative 5, when 4 minus 9 gives me negative 5. If I divide by 8, I'll get x equaling to negative 5 over 8. And that will be my solution to that one. Equations that lead to linear equations. Some fractional equations can lead to linear equations by using the least common denominator, LCD, of a sum or difference of fractions. And this may sometimes lead to an extraneous solution, which we will revisit multiple times in this class. So you should always check your answers when you either A, raise both sides of the equation by an exponent. So if I have something on both sides and I square both sides, I should check my solutions. Or if I multiply both sides of the equation by a variable expression. So if I say we're going to multiply both sides by 2x, probably should check the solution there. So here's a couple of quick examples on what I might get there. And so if we look at this equation right here, I have a common denominator. So what I'm going to do here is they want me to solve this. So since I have a common denominator, I think I'm going to add numerators first. And then that one, so 17 and 32 will give me 49 plus 2y all over y equals to 100. All right. And then here I'm going to multiply both sides by y. So if I multiply both sides by y, I'll get 49 plus 2y equaling to 100y. All right. Now, here is a linear equation where this one was not a linear equation. And so since this is an equation, it doesn't have a solution, but you couldn't plug 0 into this thing anyway because you get a 0 in the denominator. So we have a linear equation here. And so I'm going to say that we're going to subtract 2y from both sides. And that's going to give me 49 equal to, let's see here, 98y. And then I'm going to divide both sides by, let's see here, 98. So I'll get y equal to 49 over 98, which ends up being a half, I want to say. And just to be clear, if you're unsure, you can grab your graphing calculator and 49 divided by 98. And if you hit the math button, you have this little fraction function here. It'll change anything to a fraction and reduce it. So get a half. That's good. And again, since right here, I multiply both sides by y. That's this second rule right here, what we did. I should check my solution just to be safe. And so if I plug this in here, I get 17 plus 1 half over 1 half plus 32 plus 1 half over 1 half. And we need that to be equal to 100. So let's just because there's a lot of fractions in there, we want to keep moving. Let's let our graphing calculator check that for us. So let's clear all this stuff out. And so we're going to go alpha, we're going to go y equals. We want a fraction. And so the first one was 17 plus a half. So let's go alpha y equals, let's go fraction again, 1 over 2. And then we want to, again, second, oops, 1 second window, there we go, over 1 over 2. If I hit my right arrow key once and then twice, I'm over there. And then plus, and just to check to be sure, 32. That's good. So again, alpha y equals, hit my 1 for fraction. It'll be 32 plus alpha y equals 1 for fraction, 1 over 2 all over alpha y equals 1 over 2. And if I did everything right, I should get 100. How about that? So that one checks out. We are good there. Final answer is y equal to 1 half. That is correct. Okay, let's try another one. This one's a little bit different. And so in this particular one, I don't have a common denominator. All right, and so what I'm going to do here is I'm going to multiply by the the least common multiple, LCM. And in this case, the least common multiple is going to be x minus 1 times 3x plus 1. Now I could multiply this all out, but I don't think I'm going to have to. And so I take that x minus 1 times 3x plus 1, and we're going to multiply that by this whole fraction. So 4 over x minus 1 plus 6 over 3x plus 1 equaling to 15 over 3x plus 1 again. All right, so when I multiply this expression here times this first fraction, well, I've got an x minus 1 on the top and an x minus 1 on the bottom, so they will cancel. So in this particular instance, all I'll have is the 3x plus 1 times 4. So I'm going to write that. 3x plus 1, and then I will multiply that by 4. And then plus. Now when I multiply this whole expression times this second fraction, the 3x plus 1 and the 3x plus 1 cancel. So I'll have 6 times x minus 1. And then when I do the x minus 1 times the 3x plus 1 times 15 over 3x plus 1, the 3x plus 1 again will cancel, and I'll have 15 times x minus 1. This is now a linear expression. So here I'm going to distribute. And what I'll get is when I distribute the 4, I'll have 12x plus 4. And then when I distribute the 6, I'll have 6x minus 6. And then when I distribute the 15, I'll have 15x minus 15. All right, so I'm going to move x's to the left and integers to the right. And so I'll have to add 6 to both sides, and I'll have to subtract 4, so it ends up me being basically adding 2. So I'll have negative 13 when I add 2 to that side. And so 12 and 6 is 18x. And when I subtract 15 from that, I'll have 3x. All right. And so I'll get x equaling to, let's see here, negative 13 over 3. Now, let's see. I suppose we'll have to just go ahead and check that. And then again, let's do it with a graphing calculator. So I got 4 over, oops, let's clear this all out. Let's see, so second fraction here, it'll be 4 over, let's check to make sure I got that right, x minus 1. So I got negative 13 over 3 is what I'm thinking that is going to be. Let's see here. Alpha y equals 1 negative 1 3 over 3, and then it was minus 1, I think. Yep, minus 1. And then the next one there was plus, and so alpha 1, let's check to make sure, 6 over 3x plus 1. So 6 over 3 times alpha negative 1 3 over 3, and then gotta put my parenthesis there, and this one was plus 1, and I'm going to hit enter there. That's going to give me negative 5 over 4. And so now I got to check to make sure it's equal to that. So 15 over, all right, so 15, yeah, let's clear that out, sorry. Second y equals, got 15 over 3, parenthesis, alpha, so negative 13 over 3. Oops, I don't want that parenthesis there. So I'm going to go back and I can delete, go to that, hit my parenthesis, hit plus 1, and hopefully get negative 5 over 4. So the left and the right hand side both equal. This is my final answer, and I am good for that one. Finally, it says, given the following equation, solve for b. So we want to solve this equation for b. We want to get b by itself. And so the first thing I am going to do for this particular one is I'm going to multiply by 2. And by multiplying by 2, I'll get 2a, and then I'll get the half to cancel here. So I have, oops, come on, give me back my, so I have a plus b times h, and here I'm going to divide by h. That'll give me, and I'm going to flip it, so I'll get a plus b equaling to 2a over h, and that's an h. And then I'm going to subtract a, and that'll give me b equals 2 equals 2a over h minus a, and that'll be my final answer for this one. Okay, so that brings me to the end. Marvel fun fact of the day: the original Nick Fury was white and fought in World War II. The character was rebooted in the 90s, and the writer Mark Millar based the new version on Sam Jackson, who was eventually asked to play Nick Fury in 2008's first MCU film, Iron Man. That's all I got for today, folks. Have a good one.